all on behalf of the Department of Electrical Electronics Engineering program on advancement in IoT and AI for smart cities, green mobility, SDG-driven urban transformation. This FTP is sponsored by AICTE Atal. Our speaker session is Mr. Pradeep, who holds PA and ME degrees in electrical engineering and senior power system engineer at Power Projects. His expertise includes power system studies, renewable integration, and power quality enhancement. Sir, we welcome you.
Thank you, ma'am. Thank you for your warm welcome. Very good evening, everyone. So we are Power Projects, right? So we are actually 90 members strong team. So including our Bachelor of Engineers, Masters of Engineers, and PhD holders also. And pursuing Masters also is occupied with the 20%. Then remaining Bachelors 45%, Masters 25%, PhD 10%. So we have completed nearly across 42 country projects. So our project count also have exceeded 650. So across variable sectors like renewables, data centers, power plants, ONGC, oil and gas, mall and commercial buildings, offshores, so transmission planning, including steel and cement plant also we are working across various sectors. So our services are mainly focusing on projects and working on projects, power system that is included. So in various trainings also we are conducting, like for 1 credit course, 2 credit course, and from the starting from the scratch, if you are new to power system, so that courses also we are started with in our training, then detailed engineering. So these are our software expertise, ETAP, Dixel, and PSCAD, PSSC major. Then Dialects, PVSys, Homer Pro, and Homer Grid are some other additional softwares also. Then these are our power system studies, including our scope. Our engineering services also we are providing. So these are our prestigious customers, including Acme Solar, ABB, GE, Inox Wind, Siemens, L&T, including many of our prestigious customers, right? So in the training part I have mentioned, right? So in that we are offering various types of courses. So if you check this Power Projects website, yes, so this is our home page. So in this we can there are various courses. So in this scroll down and just select the category as free courses and check on that. Surely this will help you as an electrical engineer. Preview of power system analysis and reactive power compensation and career guidance for TNC. Right. So then moving to the slide. Yes, it is in presenting mode. Then don't forget to follow us in our LinkedIn. So where all the updates of our upcoming webinar programs, including free masterclass, everything will be described in LinkedIn, YouTube, as well as Instagram, right? So just type Power Projects in LinkedIn and follow. Now, with this short intro about our organization, we can our today's session. Right. So as just a second. So IoT, we are starting from Internet of Things. So as Madam have already given intro, so advancement in IoT and AI for smart cities, green mobility, and SDG-driven urban transformations. So this is our major topic. So in this Atal sponsored FDP, so we are going to see about, this is our today's topic, right? Low duty cycle and energy efficient communication for IoT devices. Right. In this, starting from this is the followed by the agenda. Right. What is IoT? Roles of IoT in just a second. I think this is distracting me. Yes. So I hope my screen is visible. Right. So what is IoT? Roles of IoT in power systems. Right. Duty cycle in IoT. Energy efficient communication protocols. Main protocols for low duty cycle IoT. And what are the circuit and hardware approaches we require for this IoT? Then optimization strategies. Then where to apply the IoTs and including a real-time example also. What are the challenges that we are going upon inducing IoT? What are the challenges we are going to face in IoT? Then finally, a renewable structure in India as an additional topic we are going to see that also. Right? So what is mean by IoT? What is mean by IoT? May I get some responses in chat? What is mean by IoT? Whether after including a topic and seeing the topic, whether you have gone through what are IoT and where it is used. Just give me a second. Just yes, Internet of Things. Yes, that is expansion. Why we are using this? Why IoT? So previously, as an existing system, we are going without IoT as of now. So what is the purpose of inducing IoT in our power systems? Yes, connecting everything. Thank you, sir. Where we embed an advanced technology as the combination of both electronics and programming language together. Yes, of course. Thank you. Thank you all for your response. Let me present my screen again. That is what we are going to see in our today's session also. So IoT means an emerging paradigm of internet connected things that allows the physical objects or things to connect, interact and communicate with one another, similar to the way humans talk through web, right? So it is not like directly connecting the machine as well as with any other things, but that is in, of course, the protocol is saying like that, but how to say means intelligent connections. So everything, whatever we are connecting, the web with the things and the internet with the things. So all the things are intelligently connected, right? So which we can monitor, sense, we can get the data, collect the data from the thing what we are measuring. So there are various examples also. We are going to see one by one. So it connects see systems, sensors, actuator instruments to the broader internet, right? So all these things are hardware actually, right? Equipments, instruments, everything is hardware upon seeing electrical point of view, right? When we are connecting it with the internet, right? It requires some space, cloud space. It requires to store all the data what they are collecting from the actual thing, that is manual hardware thing, right? So that is IoT. When coming to role of IoT in power systems, so why not only in power systems, So in various fields, IoT are induced nowadays. But as of now, my specialization area of specialization is power systems. So I'm picking some points from power system. What are the roles of IoT in power system? So majorly, so whatever may be the things we are doing in the field, like fault, in case of in the fault in any switchgear is subjected to some fault due to any external thing. So at the time, we are in our workstation with master computer, whereas that switchgear will be in the field nearly 2 to 3 kilometers far away from the master computer. So once it got tripped, if the field engineer is there, he will be directly going to the field and he will be analyzing. So what is the fault like that, right? But it will take time. If he may or he may not be, right? He may or may not be recognizing the fault. But when all these things are computer connected, that is internet connected, all the things and the data will be stored in our master computer itself. So whenever there is a trip, suddenly the switchgear got tripped or any one portion of the entire system, power system got tripped means we will be immediately getting the communication. Like we can set whatever may be. We can set an alarm or alert signal, whatever it may be. So upon receiving this, so from this place itself, I can able to check, okay, whether my system is operating in a proper stable condition or not, whether it is facing any some how to say any faults or disturbances when it is coming through without connecting with the IoT. It will be taking some quite lot of time, but when it is computer connected, right, it is completely how to say means each and everything is monitorable. So for that, various components will be used. So that is what given here. So the use of wireless technology to connect power industry assets. So asset means all our equipments will be costlier equipments, right? All our equipments will be costlier equipments. In this case, if you are subjected to any fault immediately, so at the time, due to protection of that equipment, so if we sense the fault previously means we can able to save that equipment. So for that, all those things we are using this IoT. In energy systems, IoT significantly improves their efficiency, and it is a network of connected devices that exchange data. Yes, of course. So again, the same points. It will use sensors, actuators, everything to store it in the cloud. So what is the base medium of this IoT? Whatever may be the data we are collecting in the field, or not only the field, I'm speaking about power system point of view. So whatever may be the data we are collecting from the field, all the data will be stored in the cloud as a section wise. So on this day, at this date, at this timing, this is the recorded data. So like that, the previous data will be accumulated in the cloud, right? So enabling faster data interaction while maximizing storage capacity. When applied to power networks, so such advancements like intelligence grids also sometimes, that is smart grid we are saying nowadays, right? We are in way to achieve the smart grid network to enhance our grid, actual grid which is present now. So we are in a way to um, achieve that smart grid within the year of 2030. So this is the process flow of IoT in power system. So first it will be sensing, right? Our first step is sensing, followed that connectivity, power management, cyber security, complexity and sensor reliability, finally environmental security. So what is mean by sensing? For example, let me consider a simple switch gear in field, right? In this switch gear, I hope everyone is electrical department and knows what I'm speaking about switch gear, fault, everything, right? In this, here fault, any fault is happening, double line to ground fault is happening, something I'm assuming like that. So suddenly this switch gear got open to protect each and every switch gear will be provided with the protective systems to protect this switch gear from this fault. Switch gear got open, right? This open connection, that is what sensing. This will first sense this. So suddenly the fault is inducing, so that my switch gear is reacting. It will sense first. Then connectivity, where it will connect to the master system, where the master computer or master system, the substation will be there, right? It will connect this to that master computer. Suddenly it will give the immediate alert signal or alert node, anything. Right after that, the power management means that is the evacuation. So in case what is the cause of fault, when it occurred, due to what external source it got occurred, like that, the complete root cause analysis can be also able to find here due to this. Because why? Because everything is continuously monitoring due to the internet connected things. So even though when any attack or cyber attack or due to external agents, if the fault is occurred, means all the things will be able to easily findable, right? All the things is easily findable. So then cyber security, that is whether we are going to check whether it is from the technical point of view, that is manual point of view, any fault is occurred, or else due to all the data are stored in the cloud, right? Hope, as I said in the beginning, all the data will be stored in the cloud itself, right? So the cloud can be, how to say, means the hackers can able to hack that cloud and able to collect all our data, right? So that is what cyber security. Then complexity and sensor reliability and environmental security, which means, so once everything got cleared means, so the system will again, we will be bringing that system to the normal state, right? We know the power system operating states, normal, right? Alert, in emergency, in extremis, restorative. So finally it is normal, right? So once all the things is completed, it will be bringing back to again normal state and it will be operating again. So suddenly, not in this switch gear, in any other switch gear other than this or nearer to this, if it is subjecting to the fault means, again the same process will be repeating. Right? In power system point of view, IoT will be working like this. So for this, the sensor, there are various and various types of sensor nowadays that are available. So someone to sense the temperature, someone to sense the humidity, moisture, the voltage level, and the current level, everything we can able to manage with this IoT. Clear? So these are the examples. So before that, let me check any comments or questions. So in Google Meet, this is the issue, right? We have to. Yes, of course, home appliances connected to the IoT. Yes, so 10 minutes once, 15 minutes once, let me check the chat. In case any discrepancies or questions you are facing, right, kindly post it in the chat. Surely I will answer. Yes, so again, we can follow this. So examples, there are various and various of examples nowadays using the IoT itself. So one is Madam have posted in chat. So I'm following that SCADA monitoring, smart metering, building automation, smart grid, and public lighting and the traffic control. So there are some IoTs which is supporting agriculturals also, then healthcare, smart appliances, and a smart city, that is scheme of government of India. So starting from SCADA monitoring, so already in the substations, all the data, the voltage, the current, power, reactive power, all the data is managed by SCADA monitoring only, right? It is a hardware structure. It is nowadays it is collecting only, right? After collecting, if you are facing any issues or over voltage, if you are facing means it will collect all the data, right? When it is internet connected, IoT connected only, it will start to react, right? And it will give some alert signals, everything. Then smart metering, what is mean by smart metering? So nowadays in our homes, that is our Tamil Nadu Power Distribution Corporation have started to replace the old meters, right? Electromagnetic meters, everything with digital meters. So those are digital meters, not smart meters. So even though the digital meter is there, additionally, externally, a person from EB is coming, right? He is taking the reading and he is saying, so this much is the bill, like that he is saying. So what meter we are having nowadays, like it will be having a white glow or else green glow in some cities. Those are digital meters only, not smart meters. So then what is meant by smart metering? Each and everything, the units what we are consuming, it can be accessed by EB personnel also. That is the EB system, Tamil Nadu Power System Corporation, right? They can also access how much unit we are consuming, time to time, day to day. They can also monitor, right? But as of now, whether that system we are having in our state or country, answer is no. Why? Because an external person coming with the EB meter, that is the reading meter, and he is taking reading and he is providing the bill to us, right? So this will take, surely it is possible. If you ask whether it is not possible, means it is completely possible. The only constraint is the amount, right? The price consumption, that is including of buying the smart meters, right? That is more huge. So the normal persons, like those who are so some of them may be daily wages, working for daily wages. So those people cannot afford this smart metering. But if it is making it as a mandatory rule, so surely government have to provide some subsidiaries, at least to the persons, those who are working, like considering the financial constraints of those families, surely they have to provide some subsidiary and consumers amount, and they have to buy this smart metering. So once the smart metering is there, so all the things are easy. So, but the person, those who are coming with the meter reading, so he will lose the job. Why? Because all the units what we are consuming, each and everything, they will be fixed, right? All the things are fixed, and they have write the coding program, everything. So on the 31st of the month, if it is coming, or 30th of the month, if it is coming, means automatically it will generate the bill, how much we are consumed in the previous month, how much in the first month we are consuming, and what is the total bill, and it will be sending us an SMS to the consumer, right? But nowadays, upon the first step, what we are also going to move towards the smart metering is, so our Aadhaar connection, right? So everyone have done in our home. All our EB connections nowadays are Aadhaar connected. So not only in EB, all the things are nowadays Aadhaar connected. So what is the first step towards it? Aadhaar is having all our personal data, right? Including our demographic data as well as biographic data. So once, for example, if in my home, I am giving my Aadhaar card and I am registering for EB, means, so my entire data will be maintaining with EB also. Upon providing the number itself, don't consider it as we are just giving the number alone. You are giving all your data, including your demographic as well as biographic data, right? So for that, proper cloud structure with proper firewall to attack the cyber security must also to be provided. Or else, upon collecting all the data from us, they are maintaining in a cloud, like a TNEB cloud, like that they are maintaining. Suddenly, in case any cyber attack, if they are forcing, means if the firewall is not strong, right? So at the time, the hackers can easily can hack all our data. That is not the only the consumer numbers data, but all our personal details also can be stolen. That is the only constraint upon implementing this. One is cost, the second one is cyber security. Or else we can change the priority, like the first one is security, second one is cost, right? Building automation. So for representing building automation alone, I have presented a simple network diagram here. See, this is the home. So in this, starting from here, smart TV with the voice control, right? This is, everyone knows, smart cleaner. So voice control, just saying, like there are nowadays different, like Amazon is providing Alexa, right? Like that, different structures are providing their own artificial intelligence structure which will assess the humans. So just if they are saying, like, play this music, play for or else dial this person, like that, if you are the entire system, if it is connected, means that system, if you are saving the contact properly, and if you are just saying dial to this contact and we are saying their name, means it is automatically dialing, right? So that, like, that much improvement we have had in our AI plus IoT also included. So smart TV, just to turn on the TV, if you are giving the command like that, the TV will be turned on. This temperature control, these are sensors and actuators, and how to say, means there are electric transducers are also there. So if the temperature going beyond this, if we set the temperature like that, If it is going beyond like that, automatically the AC will be turned on in summer. Similarly, in the winter, the cold, right? If the cold is going beyond this much temperature means automatically the room heater to be turned on, right? Similarly, the voice assist whenever there is the light is glowing, so it will we can place some motion sensors. So if there is any motions that is crossing beyond the nearer to the chair or else opening the door, so automatically the light will turn off after 2 to 3 minutes, right? But when it is mechanically without any IoT devices, we are there means when we are going to any city and we forget to turn off the any lights in our home means if it is a normal home, until we are coming back, the lights, entire thing will be glowing only. So there is no chance of turning off all those things, right? But when we are changing our home like a smart homes, there may be the possibility of including all the IoTs. Even in our mobile phone itself, we can check in which room which light is turned on. Okay, I have forget that. We can turn off using our mobile phone. So that much improvement we have done in our IoT. So see sensors, everything, Wi-Fi, everything. All the things are. This is the common bus which is connecting the like you can see all the entire home is provided with this common bus, right? All the things are voice control and everything. So that is up to building automation. This is just a small home like I have mentioned. In how to say means in corporate building something. So I have seen like in one video that is everyone. I hope everyone have watched. So that is actually a conference call. So in that after the finishing the meeting, right, the chairs are actually scattered here and there. It is not in the proper position, right? But once when they are about to leave, they are entering in the room. They are just clapping their hands. So the entire chair got arranged in their own position again, right? So in that case, what it is representing means that is making how to say means the man as well as the manpower to reduce the manpower, or else there's another person have to arrange that. If the conference call is small, it is okay. What if it is 150 members that like a conference call is there means? So these types of technique can be adapted, right? Our time is also saving, manpower, man energy is also saving, of course, right? Then smart grid, that is what I have mentioned. Now, the smart metering is the first step of smart grid. The smart grid means the entire power grid. As of now power grid is, we have started actually. Now we are not fully connected with the smart grid. If you ask means our Indian grid, as of now, it is not fully connected. But we are in a step way ahead to achieve this smart grid, right? In the similar way, public lighting and the traffic also. The traffic, everything with an image sensor. So the AI can automatically sense, the IoT can automatically sense where the traffic is huge and which should be opened first. But if it is a manual control, they will be programming this. So however may be the traffic, even though the a four road is there, in one road there is no traffic means for that time 2 minutes or 3 minutes we will be waiting and then coming back to next turn. But when we are introducing these IoTs and traffic control, it will sense where the traffic is huge and that will open that traffic first. Similarly, any emergency vehicles if they are facing, so at the time, according to that emergency vehicle, the traffic can be changed. Due to why? Because that is our first priority, right? The public lighting also similarly, agricultural IoT. So from our home itself, we are watering our plants, watering our in the field directly. We can water instead of going there directly. And with some smart cameras, we can able to check the field also. So whether the water is properly going to the plants or not. Healthcare, this one. So nowadays, everyone started to wear a smart band in our hand, right? Smartwatch in our hand. So in this also, this news also, everyone have heard about it. Surely you will be here. So that smartwatch, I think from grandfather or grandmother, I don't know, they have wear. So their pulse rate got below the normal level, right? Due to that grandfather got fainting and he got he fell down actually. So what this smartwatch do? It sends it automatically and it gives the signals to the sons. Immediately it has transferred this data to their son mobile. So suddenly he came and he got saved. So due to the smart applications. So nowadays, even that pulse monitoring up to itself, our IoT have induced in our day-to-day life. Smart appliances also. Smart city. Actually, this is a scheme introduced by our government of India. So they have picked some nearly 600 corporations, right? In our Tamil Nadu is also included. So in that various types of projects, what is meant by smart cities? So proper waste management, proper sewage management, right? Utilizing the green energy more and more. So for street light, everything, instead of depending upon the power distribution corporation. So in the daytime, the solar energy, or else using some small wind turbines, we will be generating energy and storing using some sensors and actuators, or else upon scheduling from 6 p.m. to 6 a.m. Like that scheduling, automatically the street lights, everything will be turned off in the highways, everything, so that a city can be turned into smart city. Upon disposing the waste properly, like degradable, biodegradable, everything will be coming. Using the vehicles like mostly EV, non-polluting vehicles. If we are using the diesel engines or petrol engines, the most updated version. As of now, BS6 is the most updated. And our Tamil Nadu government have started also the public transports. Nowadays, if you see means new buses which we are coming to the public transport, they are actually BS6, right? So upon using like this, a city can be transferred into a smart city, right? As of now, as per the statics, Tiruchirappalli is holding the first position as of now in Tamil Nadu, and the second place, our Coimbatore only, right? They are in, where the statistics I'm getting from is that is from the government website only. If you check means upon, I think nearly 100 projects allocated. So in that, nearly 80 projects are completed in Trichy district. Similarly, in Coimbatore, once the metro got started, so that is also one of the project, right? It including all the sustainable as well as conventional and non-conventional sources that will be convert the city from normal city to smart city, right? This is the simplified diagram in our power system, how IoT plays the role. See, it is, let us start from here. Energy democratization, digitalized energy generation, preventive fault and maintenance, optimized energy grids, distributed energy systems, energy management, demand response, smart buildings, energy efficiency, smart mobility, including that EV I have mentioned, right? Virtual power plant. All these things can be achieved using our IoT in our power system side, regulations and markets, utilities and generation, transmission and distribution. This is our consumer side, demand side services. So what is mean by demand responses? All the data will be how much we are consuming. All the data will be monitored and stored in the cloud, right? So these data can be used for forecasting. So in the upcoming next 10 years, how much power I need to generate for this specific location, right? For example, our Coimbatore region alone, let me pick. So past 10-year data, already they have collected all the data, how much it is generated, how much it is consumed, how much it is gone as losses, everything they will be calculated for the previous 10 years. So starting from 2015 to 2025, they have pre-calculated that and they will deciding the tomorrow's demand. Why? Because all the energy what we are using now is continuously generating. It is continuously generating. We are consuming and depleting, right? So for tomorrow, we have to schedule how much have to be generated for this Coimbatore region alone. Like that, we have to decide and we have to work on that. That is, the grid engineers have to work on that. So for that, this IoT will be helpful. Let me check any questions. Just feel free to post. As of now, there is no questions, I think so. If there is any questions or clarifications, or else if you are having any points means also, you can post here. Yes, so let me go to the presentation back. So duty cycle, we know everyone have our electrical background and we have studied power electronics also. Right, in simple terms, the proportion of a time a device is active versus in lower power sleep state. Right, for example, if a switch control, I'm just taking an example of switch control alone. That switch control, that the purpose of that switch is only to turn on. That is the only thing. After that, that switch is not required. If the case is like that means, but before inducing in this duty cycles, that switch will be entirely present in the system, even though if it is not required. But once it is converted into IoT and the duty cycle is there means, so wherever it is required, at what time duration it is required, for that alone it will be active. So remaining time it will be going to sleep. Sleep means it will be ready to operate whenever it is required. But instead of presenting in the circuit for the entire duration, it will be operate whenever it is required. Right? Reducing the duty cycle minimizes average energy draw, but requires careful scheduling of data transmission and sensing. Right? So upon reducing this duty cycle, it will reduce the energy consuming from wherever it is consuming. It is consuming from either a battery, that battery energy will be stored and it will be maintained. Or else if it is consuming from directly the source, that is our power source, at that time also we can able to reduce that power consumption. Right? Adaptive duty cycling. So this is depending upon the traffic of the load, when it should be operated or when it should be not operated. All these conditions will be proctored and monitored continuously. It will be having adaptive and intelligent controllers, as I have already mentioned. So according to that, it will be oscillating and it will be performing. Right? These are some of our main protocols. So nowadays it is used in IoTs. So LORA means that is nothing but low range. LORA is a separate type. LORA WAN, wide area network, that is the separate one. Sigfox, NB-IoT and LTEM, Zigbee and Bluetooth. Zigbee, I think everyone aware about this. Bluetooth Low Energy, BLE network. Right? These are the communication protocols. But we have to induce the IoT in the power system. Surely we require the IoT which will connect with our power systems, right? So for that, there are various of protocols are there, communication protocols are there. Most commonly used so far in the industry, I have seen, I have picked some of those and shown here. Sigfox, Zigbee, all these things. What it will do, the same process, all the process what we have mentioned in the previous, that sensing, monitoring, cyber security, firewall protection, environment sustainability, sensor reliability, everything will be monitored using this IoTs. Right? Circuit and hardware approaches, we require more and more devices. Why? Because many small sensors are there. Right? We require this. So use of ultra low power microcontrollers and transceivers, such as sub-threshold logic operation to drastically cut power, right? And the DVFS, sometimes dynamic voltage and frequency scaling. So this is that, this representation is DVFS actually. DVFS, performance analysis, voltage and frequency scaling, right? Clock and voltage control, feedback mechanism, testing and verifications. So this is actually, everything will be requiring some other devices also, like microcontrollers, micro processors, transceivers, the transmitter as well as receivers, and some analog to digital conversions. Everything is required here. And the DVFS also, dynamic voltage and frequency scaling devices are also required here. Right? Efficient sensor interfacing, selective sensor wake up. Right? That is what we have mentioned as the duty cycle previously. So whenever it is required, it will be wake up. Whenever it is not required, it will be ready to wake up, but it will be in like a sleep mode, similar to our system PC. What we are doing when we are not using, but you are going to use after 2 hours means we won't shut down it, right? We will be making it as a sleep. So after 2 hours, when you are working, we will be bringing it back again. The same procedure in here also, right? Optimization strategies. There are two layers majorly when it is coming to uh, this IoT. One is communication and the another one is network, right? And the communication using the energy efficient communication protocols like LORA, WAN, Sigfox, NB-IoT, LTE-M, Zigbee. With these, we can adapt all these things, right? Duty cycling, adaptive power, I have mentioned. Data aggregation and compression. What this means is cumulative of data. For example, starting from 12:1 today, 12:1 a.m. to 11:59 p.m. today, it will be collecting some data. Any, how to say, power profile we can, all are simple terms, voltage profile we can say. For a specific location, specific area, it is collecting the voltage profile means the data, everything will be aggregated as a single data, as a single folder, and it will be stored. It will be compressed and stored in the cloud. So whenever we require 12th September's data, voltage profile data, if we need means, we will be able to retrieve the data from the cloud. Right? Protocol selection based on application. That is what type of communication protocol we need for what application. Each and every application are not have each and every protocols are not having the similar functions. Each and everyone will be having at least a unique function to perform. Right? So when it is coming to if you are picking a Zigbee, or else we are picking a LoRa WAN, right? It will have its own specific applications, right? Depending upon what type of application we are providing to the system and how it is going to activate, how it is going to act to the system, depending upon all those things, it will be coming back, right? The network layer, mesh network, it is Zigbee, it will be using star or topology network, it will be using LoRa. Then topology optimization, again, depending upon the system, we can use the different protocols here. Right? There are various things are there. So this is the 3-layer structure of IoT. The one is application layer, network layer, perception layer. Right? Application layer is the cloud or servers where all our data will be stored. That is known as application layer. The second one is network layer, where we can able to at least to operate all these things. So kindly think everything must be connected in a single Wi-Fi network, or else each and everything should be Bluetooth connected. Then only it is practically possible, right? Without that, with the mobile alone, we cannot able to do either using the Bluetooth we can do, or else using the Wi-Fi, that is LAN network, we can able to do using the routers or gateways. For example, in the normal home, if we want to convert all these things means we have to install the Wi-Fi. That is mandatory. That will be an additional charge and additional burden to the consumers. Some of them maybe think like that, but some of them, okay, even though we are installing the intelligent controllers and intelligent systems, that is okay for me. Like that, they will be doing like that. Right? It depends upon the consumer to consumer, whether they are adapting or not. Then perception layers means that is the ground level, the sensors. So, for example, I am speaking. This is the how to say light sensor I am placing. Light sensor means including the motion sensor. In your room, I am sitting here. Right now, all the sensors will be focusing upon my chair and this table. Right. So the signals will be cut off. Right. And the signals will not be closed. I am here to interrupt. Right. So that the signal will be interrupted. So that it will be sensing like someone is there. So the light should not be turned on or turned off. Like that, it will be sensing. So until I'm sitting here, the light will be turned on. So once if I'm if I'm getting any work and if I'm moving from this place means, after that, what it will do, it will wait for few minutes. So once the signal got closed, right, that sensor signal got closed, so it will sense the signal is closing, no one is there to interrupt. So now the light should be turned off. Like that, it will be sensing, and automatically using this intelligent controllers, using the IoT, it will be turned off. But all these things must be either Bluetooth connected or else Wi-Fi connected. That is using the routers we have to connect. Right? That is the perception layer. That is the ground level. The network layer is the routers, whereas the application layers, the cloud or the servers. Everything will be stored in the cloud or the servers, wherever the Wi-Fi they have installed. That is the first layer, application layer. Similarly, 5-layer architecture is also there. Right? That is the advanced to this 3-layer. Right? That is not required here. That is a bit complex thing. Right? Let me check any questions is that I'm moving forward continuously without checking. Yes, I'm expecting some questions and to making this session as an interactive one. Thank you. Good evening, everyone. Right. So major applications are IoT sensors for power system monitoring. Right. When it is coming to this IoT, we will be continuously seeing like the sensors, area monitoring, wide area network, LAN connections, routers, Wi-Fi, all these things. Why? Because within this simple network itself, our system is ready to work properly. Right. That is IoT sensors for power system monitoring. Right. Integration into substations, distribution assets, renewable plants. Sensors communicate infrequently, but must be ultra reliable. Right, wide area monitoring, that is LoRa and NB IoT, used for line status, fault detection. So these are used in the field to detect the fault. Equipment health crucial for grid stability, grid compliance with regulatory standards. Also, we will be using this. Then demand response and AMI, advanced metering infrastructure. So in here, as much as low duty cycle will be used here, including the various communication protocols I have included there, right? That will be used here. Right? Challenges is the only challenge is the cyber security, the data attack. That is the only point of view when it is coming to IoT. So in this is actually a real-time example. I have selected one real-time example to show you all. So see here, one of the biggest challenges of implementing millions of new devices for a smart grid is that each of these devices could become a potential target for hackers. Being in the sense, security, a vital point to be solved with full safeguards against intrusion by a third party. So we are collecting all our data and we are storing it in the cloud, right? If the hackers directly hacked the cloud means, what will happen? All our data, stored data, forecasted data, included previous year's data, including our personal data, everything will be transferred to the hackers. Right? With that, they can able to do whatever they need. Right? So similar event is occurred in Ukraine. In Ukraine, power system attacks happened on December 23, 2015 at 3:30 p.m. Right? Tracker Patia, right? He is actually one of the power grid employee there, right? Using their channel only, using his channel only, he is actually the grid corporation people, right? So using his channel, they have hacked, right? Nearly 27 substations using that, because all the substations, entire control will be in their protocol, right? In their communication protocol, that the entire 27 substations went dead. Nearly 103 cities, major cities in Ukraine, were completely blacked out, and additionally 186 six cities were left partially in dark. Right? See how much risk it is. If it is, when it is turned to be risk is when we are not properly maintaining the cloud and we are not properly protecting our cloud. Why? Because all this data, wherever we are receiving from the IoT, everything will be stored in the cloud only, right? When it is not stored in the cloud, when it is not protected properly, the cloud structure, then the hackers can easily do like this, right? So the control centers were not fully operational even after 2 months later. So at the time, even after 2 months also, they can't able to retrieve the connection and bringing back all those connections back. That is the only constraint and one of the severity upon adopting the IoT in the real time. So we can say like we can provide the additional security using additional protective walls, firewalls, everything we can use like that, we can say. But that will cost us huge. That will require additional servers, right? Similar to that, uh, we can increase, but the hackers, they can easily able to decode everything, right? Even though if you are protecting that much as possible, all the data, why? Because this power grid, Ukraine power grid got hacked, right? That is actually a government power grid. Everything got hacked, and nearly 1 or 3 cities were completely blacked out, right? So when we are adopting it in the our normal day-to-day life, we have to be a bit conscious and we have to check all our cloud data and our cloud protection level first. Then only we have to induce in that is not in our life. We are saying that is in first our power grid have to implement that. Followed that we have to. It will be a major. Usually they will be starting with metropolitan cities. Then from that major cities which are they are contributing, they will be like metropolis in India level. If we pick means Chennai, Mumbai, New Delhi, and Kolkata. When in Tamil Nadu level, if you are picking majorly like Chennai, Trichy, Madurai, Coimbatore, like Tirunelveli, like that. That major cities alone, it will be we will be picking it first, right? So this is the step by step Ukraine power system attack step one. So this is Prekapatyas network, IT network, right? So this is, if you see the symbol like this, the hackers have induced here and they are waiting for this data to collect the data from this master computer. This is the master computer. I hope my screen is visible. What they are doing, they are providing some virus files, related files, and they are sending to this Prekapatyas network using an Excel sheet, not that much complicated. Using just an Excel network, Excel sheet, they are inducing that virus and they are sending to this Prekapatyas network. What Prekapatyas is doing? Okay, some data have received from like any managerial positions. Our IMD have sending like that. He has think and he have opened that Excel file. That's all what happened. He just opened that Excel file where the virus is there. That is what our nowadays entire cyber security network and our police they are insisting us not to touch any links. Right? They will be what they will do. They will if you just touch the link means immediately 10,000 rupees will be credited to your account. Or else if you just do a task for just 3 hours, nearly 1 lakh will be credited to your account. Right? However, it is booming in a good way. In one side means the hackers are using the same thing for hacking as well as easily they can able to uh, using this as the medium. They are how to say they are stealing all the people's money also nowadays. That is what the power system even they have collected, including all the things. If you are playing a game, we are betting. So at first 3 times that logic will be working like that. First 3 times you will win and you can able to take account. As a human being, whether we can stop that our desire, surely no. What we will do, we will invest all the amount what we have collected that 3 times, and we will invest. At the fourth time, the coding will be work like we will have to pay like that. It will be turned like right nowadays. Everyone is addicted to that. In that is depromoting this IoT upon inducing it manually. That is also one of the reason. Right. Let me come back here. Prekapatyas network. So he's just sending an Excel sheet with the virus. Prakarpatya unfortunately opened that. So this is the step 2, right? This Prakarpatya's network, that Excel file, that virus started to moving toward the IT network, that pipeline, everything. Malware connects the distant CNC server. What it will do, it will connect this main server with the hacker server. Hacker servers will be changing the time to time, seconds to seconds, fraction of fractions to seconds. It will be changing, right? It will be connecting this network. It will be directly, it is like presenting your screen to the hackers. Like that, it will be connecting the network to the hackers. So network stand hops to another host. So whereas the hackers will be taking the host control. Detects an open SSH tunnel to OT, keyboard stroke recording. See, and the supervision, everything, the starting from the, this is IT network, this is OT network. So Parekar Patel's network, this is his network alone. Why? Because his network acted as the medium for this entire Ukraine power grid attack, right? Unfortunately, he has opened that Excel sheet with the virus. He don't know actually. So started from this, every data have gone through this, and directly it is forced to this master computer, right? Finally, see all the data here. This system is taken over by the hackers. See here, this is the master computer of the power grid. So forcefully, all this data is subjected to send to this master computer. So from this master computer, he got the host access, and he had taken all the control of this master computer, and he got he made like the power outages in various cities. Right now, see, now there is the system is all right, but all the data have went to the hacker's control. So the system is behaving like normal. So now the system, if it is operating normal, means who is operating? That is not the power grid, but that is the hacker. See, shutdown orders are sent through the tunnel to the breakers. So he made this shutdown orders. He or she, the hacker, have made the shutdown orders, right? And they have purposefully, intentionally, they have turned off the substations, and they have opened the substations, breaker, everything. And the fourth step is the self-destructive mode also. He have destructed all the computers. That is, the computer means the data which have stored already. The entire data he has stolen first, and he have the data he have transferred to his cloud, and finally he has emptied all the systems which is present in the power grid. So after recovering all those things, if the power grid people open the system, means it will be looking like a new system. All the data have erased by him, but all the data who will be having? Hacker will be having. Right. So this is the only disadvantage and limitations upon inducing this IoT in the real day-to-day life. Right. Hope it is understandable. Is there any doubt? Is there any doubt? Is there any doubt up to now? Whether at least if it is clear up to now, just to post it in the chat. Yes, at least that's nearly 100 are there.
Participants, you can respond.
Yes, please, so that it will be.
So if you're responding, it may be a interactive session. You will be feeling interested. Kindly respond.
Yes, of course. Karin Selvi have joined and Rasa have joined. Yes. Thank you. Thank you. Okay. Yes, now we can see generally. Yes. Okay. We can discuss something like, as we have mentioned, the smart cities also in our topic. Thank you. So we are having smart city in our topic also. So this half an hour we can spend for that. right? So let me stop the screen as of now. So could anyone specify what is the installed capacity of India? Yes. What is the installed capacity of India? Thank you. Thank you everyone for posted in chat. Thank you. Installed capacity of India, anyone? At least just give a try. Nearly 100 people are in chat. Yes, 800 gigawatt, around 450 gigawatt. Yes. So I'm not expecting exact correct answer. Just an answer I require. Even though if it is correct wrong, that is second. Yes, 500 gigawatt, around 500. Yes, where to check this 500 gigawatt? All these things you are specifying. Thank you. Thank you everyone for taking your time and answering. Where to check in the website whether it is correct or not, like that, where we can check MNRE. No, that is Ministry of New and Renewable Energy Department website. That is not, that is different. Yes, thank you, sir. Central Electricity Authority, right? So now let me show some demo of the websites. So many of them are new. I hope so. Someone are posting in chat. Yes, yes. CE only. Yes, of course, sir. So now we can just a second. Yes, Ministry of Power. Yes, thank you. So now let me present the screen back. Just a second, it is taking some time. Yes, 350 Ministry of Power. Okay. I hope my screen is visible. Right. So now let me show. So CEA, as many of them are specifying the same website only. Central Electricity Authority. Right. It is a Government of India website. In this, we can able to check what is the installed capacity of India. So upon opening right. So upon opening, see, there is a tab home about contact wings regulations reports. So in this, go to the reports, daily report, monthly report, all the reports are there. So I request everyone to visit this website individually and check what are present in the daily report, daily generation report, daily cold report, daily renewable generation report. It is updated day to day, at least 2 days. Let me check up to what is the latest report. It is updated in the daily. Usually it will be 2 days lagging. It will be having 10th September data, I hope so, or else 9th September data. Okay, see, 11th September data itself it is having, but previously this website will be slow and it will be having 2 days previous data. So as of now, see, daily generation reports as on 11th September. So yesterday itself they have updated this. The today morning they will be updating this. So daily reports, what we need installed capacity. So select on the monthly report. See here, installed capacity report. Right, in this installed capacity, see, up to July, it is updated. Let me view this. Viewing in the PDF format. So upon see here, all India installed capacity in megawatt as on 31/7/2025. See here, nearly nearly 490 gigawatt we have reached. So this 490 including all our conventional as well as non-conventional resources. Clear? If you see this PDF split up means breakdown means see north. So I think everyone aware about how many regions our power grid have classified. Our power grid have classified into 5 different regions, right? So, right, let me open this. Yes. So this one, everyone aware, right? One nation, one grid, one price. So this is our 5 different regions of our power grid, right? North, east, west, south, and northeast. So as of now, all our 5 grids are interconnected with each other, and it is formed like a one grid, one nation, one grid, right? Before synchronization, see, this is the evaluation of grid. 5 regional grids, 5 frequencies in the year of October 1991, right? In the October 1991, before October 1991, in the year of October 1991, East and the Northeast got synchronized, right? Hope you see means it will be 2 different in colors. Let me zoom in. See here, it is merged as a single region. Similarly, in March 2003, my West and the East and the Northeast got synchronized. These 3 things got formulated into a single grid. In August 2006, North is synchronized with this central, right? So, but up to that is the last integration. So after 2006, none of the grid is integrated. We remain separate until the year December 2013. We will be coming under southern region, and our headquarters is in Bangalore. We know that up to December 2013, we remain separate only, starting from 2006. Right? In December 2013 only, our Honorable Prime Minister have made the order to integrate entire grid and to make it as a one nation, one grid, one price, one frequency. So with this motto, our power grid engineers have worked in our POSOCO, right, Power System Operation Control Body. Now that name have changed like Grid Controllers of India, right? POSOCO, everyone knows that they have worked continuously and they have integrated one frequency post 2013. So that is in the December itself, we have successfully integrated this, right, with respect to our Prime Minister's order. So once it is completely integrated, now our entire India is operating under a single grid. So what is the use of this interconnection? For example, in my southern region, I'm generating, example I am saying, I am generating a 2 gigawatt of power. And just example I'm saying, just to making that round figures, 2 gigawatt I'm generating, 1.5 gigawatt I'm consuming. So remaining 0.5 gigawatt, where it will go? Before it is synchronized, it is interconnected. That 0.5 gigawatt will be going as losses only. We cannot able to, we can, if the battery energy storage system is there, means we can use them to charge the batteries, right? Other than that, we cannot able to properly utilize that form of energy, right? So what we are doing, when it is interconnected like this, so due to any reasons in my western region or eastern region, 0.5 gigawatt is required due to some any cold weather or they are depending upon some renewables. Suddenly renewables we can't able to predict, right? We will be predicting the solar for 0.5 gigawatt on one day, one fine day. Suddenly the cloud got make the sun's rays to disappear means what will happen? So at the time 0.5 gigawatt, what the power grid got scheduled, that will be required. That will be additionally they have to depend upon any conventional resources at the time. So instead of depending like that, all the 5 grids are interconnected. This 0.5 gigawatt will be accommodating that without losses. That power won't be going as losses. Instead of my eastern grid will consume that power, additional power. Similarly, I'm taking just two examples, south with east. Similarly, with all the 5 regions, wherever it is required, wherever it is enormous amount of power, it will be injected to the grid. Right? Wherever it is required, it will be consuming. Mostly it will be consumed. Surely it won't be, how to say, it won't be going as losses. That percentages, when it is interconnected, after it is interconnected, the going as losses percentages decreased actually. Right? Most of them are properly utilized. That is the main reason for interconnecting the 5 grids. Right? The main motto is that is what one nation, one grid, one frequency. Right? So region wise in that PDF, why I'm coming to region wise, they will be classifying here in this PDF. State, private, central, for each and every regions, western, southern, eastern, northeastern, and islands also, right? All India. This final column, the final row will be comprising for all India. This is region-wise classification. When we are coming with column, mode-wise also it will be classified. See here, this is thermal, all my conventional, and the thermal, coal, lignite, gas, diesel, everything will be coming under, and it will be summed up here, this total. Then nuclear, these two are conventional. This nuclear will be added here alone separately. Then when coming to my renewable, hydro, RES, MNRE, this MNRE, this split up will be given here. MNRE. So what is small hydro, wind how much, biopower how much, solar how much, this total capacity will be given as a separate split up here. So MNRE, so renewables conventional plus non-conventional, my last column comprising the total of each and every sectors. Finally, this last row, last column is defining the total installed capacity for the mentioned date. Right? By this year end, surely we will achieve 500 gigawatt. Right? You can check all the reports here. Right? In here, if you are asking what is the installed solar capacity or wind capacity, we need means this split up we can come. This is completely breakup of that MNRE breakup. Split up, sorry. Additionally, they have given some data. Meenakshi Energy Limited, Tamina TPS Unit 3 have been added with effective from 5/7. Vedanta Limited, Chhattisgarh TPP Unit 1 has been added with effective from 19/7. THDC, Terry PSP Unit 2 have been added 5/7. TS Genskos, yeah, the other 3 TPS Unit 1. So 4 units they have added newly. So far that they had given the information like this. 4 plants they have added, 4 units have been added. Like that they are providing. At what date they have added with the effective from date they are providing here. Yes, in this, I request each and everyone to visit this. So older data also you can able to see. Right, for example, in the 2021, the same September, let me check. What is our installed capacity in 2021? Let me view this document. In the year of 2021, I'm seeing. Let me see the installed capacity around. See, it is 388 gigawatt. So before 4 years, it is 388 gigawatt. Today, as of now, it is 490 gigawatt. Right, by 2030, we will be achieving 500 gigawatt, not 2030. Within this 4 months, right? 4 months pending here, we will be achieving this 500 gigawatt. So this is the one of the website, useful website. And the another one is NPP, which is National Power Portal. So this portal will also give all the data which is available in CEA portal. Yes. Okay. Okay. Yes. Link there. So the same in the dashboard. in the NPP, National Power Portal, in the dashboard, you can check, right? What we can check, the same data, like in here, like easy representation, like pie chart, everything will be available in this portal only, not in CEA portal. Let me close this. More loading it is. I request everyone to check on these portals. I think network is a bit slow from my side. Just a second, it is loading. Yes, see here, the pie chart representation of installed capacity. Directly you can view here, installed capacity, all India status. So what are the plants? Thermal, hydro, nuclear. See here, the red one, Madras. This is Kalpakam, right? Nuclear. And this blue ones are hydro, Mettur, Mettur 3. And these are thermal, Tuticorin thermal plant, and in the NLC in Kadalur. So, like wherever you need in the Maharashtra, if I'm placing here, Parli TPS, the Rajasthan, the red one, nuclear. That is the Pokhran range, right? Nuclear range. We can check these things can be checked in this NPP only, right? Now, anyone can say in our southern region, what is the frequency we are maintaining now? So for this also website is there. So SRLDC, which means Southern Regional Load Dispatch Center. It is opening in Hindi. Just a second. So Southern Regional Load Dispatch Center. So similarly, 5 regional centers will be having 5 different websites. So as we are in Southern region, I'm opening this. See, it is time to time updating. 12/9/2025, 7:21 p.m. Yes, before 1 minute. My frequency WAP we are operating here is 49.95 hertz. Right after sometimes if we are coming back here and if you refresh this website means we can see at the time what frequency it is maintaining. So southern regional demand, how much demand it is meeting? 51023 megawatt. This is the total India demands, which is now we are meeting now. That is showing here. All the things are live data. And this is how the structures will be. See in the diagram itself, the power grid it is showing, right? The smart grid setup as an initiative, it will be maintaining like this. And all the grid engineers will be monitoring and checking all the data properly and updating time to time. Right? That is what the same thing I have mentioned in the slide. Installed capacity, regional distribution, challenges, and NLDC. Similarly, National Load Dispatch Center is the common center where it is coming. From this NLDC, each one, everything will be classifying. NLDC, ERLDC, WRLDC, NERLDC, SRLDC. Like that, 5 regions are classified under this NLDC only, National Load Dispatch Centers. So depending upon various, each of the country will be having different grid codes. So our India is also having own grid codes. So due to time constraint, we couldn't able to make this. In similar, any other session in the upcoming session, if there means surely I'm ready to explain all these things. What are the grid code requirements for our India and how we are achieving this? What are the softwares, power system softwares we are using, everything. So notable renewable energy plants in our India, Badla Solar Park, 2245 megawatt, Muppandal Wind Farm, 1500 megawatt, Kamudi Solar Power Plant, 648 megawatt. Right? These are notable. Many plants are there. As of now, notable is this only. Right? Any question answer there means you can post. Right? And this is my contact. So myself, so my intro actually Sandhya ma'am have already given. So myself, senior power system engineer in power projects. So majorly working in grid integration projects. Grid integration means renewable interconnecting with the grid. Before that, we have to do some mandatory. Yes, sorry for that. A small network issue. Yes.
Participants, if you have any questions, you can ask.
Yes, please. So contact, note my contact also, my LinkedIn, my email, and as well as my mobile number. In case any queries relating this grid integration, everything means you can contact me directly. I'm free to answer everyone. So again, I want to share some knowledge also. Knowledge sharing is not a. So follow our page in LinkedIn, our projects. So this is our page actually, where we will be posting all the technical contents and what are the projects we are handled and any constraints when handling the projects, everything. Those things will be posted as a post regularly. Right. Similarly, don't forget to follow me also. So myself, this is my profile. Right. In additionally, I have to add something that I'm curious. So in the coming Sunday, right, 14th September, so I'm going to handle a free masterclass on PSCAD. So I request everyone to attend this session. Just a second, it is loading. Right, free masterclass on PSCAD. The same Pradeep is handling that session also. Right, 14th September at 6:55 p.m. Free masterclass on PSCAD basics. So if anyone already known about PSCAD software, they can also join. Or else if you want some new idea about PSCAD, what is PSCAD, anything, you can attend that session. So those who are in need also, you can share this link, share the LinkedIn profiles of mine and everyone, and this free webinar link also, upcoming free webinar link also. Yes, as of now, there is no any websites. In the softwares only, we can able to model our systems and we can able to perform the power system studies, Jasmine. So let me, yes, I first of all, I have to thank you, Sandhya ma'am. Right. So starting from the beginning, she had coordinated with me, right? Each and every instant and the updates, everything. On the call, she is doing the amazing, wonderful job. Thank you, ma'am. And Selvakumaran sir, Selvaraj sir, so coordinator of FDP. I also want to thank him for giving me this opportunity to uh, having the speaker in the Atal FDP program. So thank you, sir. And thank you for Study World College of Engineering for providing me this opportunity. And thank you once again, ma'am. Thank you all the participants, those who are attended on this website, attended this session peacefully, making this a successful one. Thank you, everyone. Thank you all. Thank you for joining. Have a great day.